Hello everyone. In this video, we are going to solve the problem number 1.15 from Irodov, and that is related to kinematics. So let us first read out the problem and then we will solve the problem step by step. An elevator car whose floor to ceiling distance is equal to 2.7 meter and that starts ascending with the constant acceleration of 1.2 meter per second square. Basically, it is starting and it is going in the upward direction with the acceleration of 1.2 meter per second square. And then 2 seconds after the start, a bolt begins falling from the ceiling of the car and it is asking to find the bolt's free fall time. So let us first draw the elevator car. So let us say this is the elevator car and it has just started. So at t is equal to 0, initial velocity is equal to 0 and it is moving with the acceleration of a is equal to 1.2 meter per second square. Okay, and this is the condition at t is equal to 0 seconds. At t is equal to 2 seconds, the car will move by certain distance and it will gain some velocity. So this is the condition as 2 is equal 2 seconds and it has moved by some distance. Okay, and it will gain some velocity v. So from the equation of motion, we can find the velocity of the elevator car at t is equal to 2 seconds. So we can write v is equal to u plus at for constant acceleration, and we know that the elevator is moving in the upward direction with constant acceleration of 1.2 meter per second square. So, and the initial velocity is equal to 0. So we can write what is acceleration 1.2 and what is the time taken 2 seconds. So velocity we can find it as 2.4 meter per second. So this is the velocity the lift has gained in 2 seconds. Okay, now in the question it is saying that a bolt from the ceiling is falling down. So when it is falling down, it was having the velocity of the 2.4 meter per second, that is same as the velocity of the lift, but as it is not attached to the lift, it will have the acceleration due to gravity in the downward direction. So let us draw the configuration of both the bolt and the lift once again. So let us say at t is equal to 2 seconds, this is the lift and the lift is having the velocity of the lift in the upward direction with 2.4 meter per second, and it is having the acceleration al is equal to, what is the acceleration, 1.2 meter per second square. Okay, as initially the bolt was attached to the lift and it is released at t is equal to 2 seconds. So basically the bolt will also have the velocity of 2.4 meter per second. Okay, but as it is not attached to the lift and it is free falling, so the acceleration of the bolt will be 9.81 meter per second square, and this is the acceleration of the this is the velocity of the bolt. Now in order to find the time taken by traveling the bolt from the ceiling to the bottommost point, let us consider a frame of reference which is attached to the lift. So let us say this is my frame of reference. This is my frame of reference which is attached to the lift. So if it is attached to the lift, it will also have the same velocity and the acceleration as of the lift. Okay, so let us find out the relative velocity and the relative acceleration of the bolt. So if we write the velocity of the bolt with respect to lift, that we can write velocity of bolt minus velocity of lift. Let us assume that the upper side is positive and the downward direction is the negative. So VB we can write 2.4 meter per second minus what is the direction of lift velocity, that is in the upward direction, so that we can write plus 2.4. So this is equal to 0. So basically the velocity of the bolt with respect to the lift is equal to 0. And then if we find the acceleration of bolt with respect to lift, that we can write acceleration of bolt minus acceleration of lift. What is the acceleration of bolt? That is 9.81 in the downward direction. So we have to write negative of 9.81 minus what is the acceleration of lift, that is minus plus of 1.2, because it is moving in the upward direction. So if we find out this one, this is nothing but 9.81 plus 1.2, that is 11.01 meter per second square minus. So this is the acceleration of bolt with respect to the lift. Minus means the acceleration of bolt with respect to the lift is in the downward direction. Now basically the bolt has to travel how much distance with respect to this frame of reference is nothing but 2.7 meter. That is the distance between the ceiling and the floor. So again from the equation of motion we can write S is equal to ut plus half at square, and here the distance is in with respect to the frame of reference, that is nothing but the distance traveled from ceiling to the floor, and then u is the initial velocity of the bolt with respect to the lift, and here acceleration is also the acceleration of the bolt with respect to the lift. So the distance we can write it as 2.7 meter is equal to velocity is 0 plus half into what is acceleration, that is 11.01 into what is the time taken is we have to find t square. So from here we can write t is equal to 2.7 into 2 divided by 11.01 under root, and if we find this particular thing, then we can get 2 into 2.7 divided by 11.01, so we will get 0.7 seconds. So this is the time taken by the bolt to free fall from ceiling to the floor. Now coming to the second problem. In the second problem it is asking to find the displacement and the distance covered by the bolt during the free fall in the reference frame fixed to the elevator shaft. So basically elevator shaft is actually fixed to the building. Let us draw this one. So basically this is the elevator shaft on which the lift is moving, and these are the floors. Okay, so this is the lift, and let us say it is moving in the upward direction. So this particular part basically it is called the elevator shaft. Okay, and this is fixed to the building. So we can say that this is the ground frame of reference. Okay, so in the second problem it is asking to find the displacement and the distance covered by the bolt during the free fall in the reference frame fixed to the elevator shaft, means fixed to the ground. Okay, we know that what is the velocity and the acceleration with respect to the ground frame of reference for the bolt. So let us say that this is the bolt, and at t is equal to 2 seconds it was having the velocity of 2.4 meter per second in the upward direction, and it was having the acceleration of 9.81 meter per second square in the downward direction, and it is coming from this particular point to this particular point, and this distance and the time taken to come from the ceiling to the floor is basically t is equal to 0.7 seconds. Now we have to find out the distance and the displacement. Okay, so let us say that it will move from this particular point to the uppermost point where the velocity will be 0, and then it will come back and it will reach to this particular point. Okay, now let us say this particular distance, let us say this is point A, this is point B, this is point C, and this is point D. We know that CD is the displacement. CD is the displacement, and from A to B, then B to C, then C to D is the total distance. Okay, the displacement we can directly find. Let us say this particular thing is uh, delta y. So we can write S is equal to ut plus half at square. What is the initial velocity? That is in the upward direction, and let us say in this particular case upward direction is positive and downward direction is negative. So the displacement is in the downward direction, so we can write it as minus delta y is equal to u in the upward direction, so that we can write 2.4, and what is the total time it is taking? 0.7 seconds plus half into what is the acceleration, that is in the downward direction, so basically minus 9.81 into 0.7 whole square. So if we find out this particular thing, we can get 0.7 whole square divided by 2 and plus 2.4 into 0.7. So we can get delta y is equal to 0.72 meter. Okay, so the distance, the displacement from point A to point D, we can get it as 0.72 meter. Now in order to find the total distance, if we know the distance between A and the B, then we know that between A and B is same as the B and C, and we know the distance between C and D. So AB we can find out as, let us say from point A to point B, the velocity is in the upward direction. Let us say u is equal to 2.4 meter per second, and acceleration is in the downward direction, that is 9.8 meter per second square, and here the velocity will be 0. So from the equation of motion, v square is equal to u square plus 2as. Let us consider the upper direction is positive and the downward direction is negative. Final velocity is equal to 0, so we can write 0 is equal to u 2.4 whole square, and acceleration is in the downward direction, then we can write minus 2 into 9.81 into s, and s from here we can find out as 2.4 whole square divided by 2 divided by 9.81, so we can get 0.29 meter. So basically the distance between A to B is 0.29 meter. B to C will also be the same, because from A to B distance is same as the B to C distance. So B to C is also 0.29 meter, and from C to D, from C to T the distance is 0.72 meter. If we add everything, then we will get the value of total distance. Total distance is equal to 1.3 meter. Okay, so the distance traveled by the bolt from in the entire journey is 1.3 meter, and the displacement is 0.72 meter. I hope the entire procedure is clear and both the problems are clear. Thank you.